Okay, so the purpose of this video is twofold. How to find the area of a triangle when we're only provided with two sides in the included angle. And this is basically looking like uh, side, angle, side. So that is a situation where we don't know the height. And then the other part of this video is to extend this, what happens when you have how to find the area of a quadrilateral when we're given the four sides and an included angle. And you'll see this in a minute. So when we find the area of a triangle, remember, if you think back to grade school, it was 1/2 the base times the height, and it's pretty easy when we are told a base and we are told a height, and of course the height the perpendicular distance from um, the vertex to the opposite side. Basically, that's an altitude. Okay, if you go back to geometry. And that can happen inside the triangle. It can also happen outside the triangle, but the base is still just the side of the triangle, and we don't know, and that height can be outside the triangle. So how do we find how do we find the area of a triangle, or how do we find the height of a triangle when we only know two sides of the triangle and the included angle? Well, I know it's 1/2 the base, so 1/2 times the base of 10, but I need to find the height. So because I have a 30-degree angle, and we do not need trigonometry for this because it's a 30, 60 right triangle, but I'm going to show you how it works with something that we know. Um, all right, so there's the height, and here's a hypotenuse. I mean, that's a right angle, so here's the hypotenuse. Here's the angle. We're looking for that, so that's I know I want the opposite side. I have the hypotenuse. That's SOHCAHTOA says that's sine. So sine of 30 degrees equals height over the hypotenuse. And then to solve that equation, I'm going to multiply both sides of this by 8.7. And then instead of finding that and writing in the answer, what I did is I said it's 1/2 the base times the height, and that whole thing's the height, and that'll be the area, whatever that is. Okay, now what about if they give me, uh, yeah, so maybe I should extend this. Let's call this side, let's call this C, let's not go there yet. So then consider this triangle here. I've got an angle side, I've got a side angle side pattern. I'm looking at 10 as being the base. I want to know that height, so I can say 1/2 10 times whatever the height is. So what I want you to focus on is you see the way the altitude to the perpendicular side to the other side is outside the triangle, and you see that this new triangle we drew is a right triangle, and the hypotenuse of that right triangle is 20. We're going to ignore the 10 because it's only part of this red triangle. So if I'm looking to find the height for this triangle, I'm going to write uh, sine 30 degrees again equals the height over 20. So the height will be 20 times the sine of 30, happens to be 10. And then we'll do 1/2 times 20, which it's 1/2 times 10, which is the base, right? This is the base for that triangle. I guess I can't erase that. 10, 1/2 times 10 times 10, I think, because that's what h would be. So that would be an area of 50. But that's one specific answer. I'm trying to build the formula. So what the formula is let's take a look at this another way. So if I'm given this a triangle, I'm drawing it as an obtuse triangle, but it works for any triangle. If I'm looking to find the area of this triangle and I have a side angle side pattern, and that's what we have here. The way you find it is we're going to do 1/2 times the base times, and now think about what I just did. If we were looking for this height, I would say it's going to be the sine of angle A equals the height over C, which would be C times the sine of A. So C times the sine of A. And that will tell me, and that's the height, so 1/2 the base, right? 1/2 the base times the height, because that's what the height is, equals area. And that'll work for any triangle that we have the side angle side pattern for. Okay, so um, that's the first objective. I wanted to make sure you learned this formula and why it happens. So here's a problem from later on in section 8.1 where we have a similar situation, except now it's quadrilateral. So let's draw a picture of what's happened here. It says 4 sequential sides, so in order, right? Have those lengths. So let's draw what that might look like. So here's the first side, which is 5.7. Here's the second side, which is 7.2. Here's the third side, which is 9.4. And here's the last side, which is 12.8. Now, and then they told us the angle in between the two smallest sides is 106 degrees. So what I can do with that formula that we just developed is I can find the area of that triangle right here, right? Using that formula. So here. So I'm going to do 1/2, and I'm going to call, it doesn't really matter what I do, I'm going to call the 5.7 the base, times, remember it's the sine, it's the other side times the sine of 106. The other side will be 7.2 times the sine of 106 degrees, and that will be the area of that yellow triangle. And you can crunch that. Now I'm looking for the other triangle, the other part of this quadrilateral. Well, I do see, boy, it would be really nice if I knew that dotted line length, and I see that it's a side angle side pattern, so I can use law of cosines for this. So I'm going to call this x. So x squared equals 5.7 squared plus 7.2 squared minus 2 times 5.7 times 7.2, the cosine of 106. So I'll stop for a minute and crunch it on my calculator. And interestingly enough, I get x squared equals 106.95 with decimals. So I take the square root of that, and I'm getting 10.3 for a length. So now I've got a triangle with those three sides. I could use law of cosines to find this angle. Wouldn't be impossibly hard. Why don't I do that? And then we'll talk about Heron's formula too. So I set up the law of cosines to find, so that I could find the measure of angle B, and notice my variable is the cosine of B. So what I'm going to do is I'm going to square the 10.3. I'm going to subtract that squared, then divide that answer by the -2 times 12.8 times 9.4. So what I did on my calculator, I squared this, and I subtracted the 12.8 squared, as you can see, and then I subtracted the 9.4 squared, as you can see. And so what that left me with is -146.11 equals, and then I multiplied those three numbers together, and I got the negative 240, negative 240.64 times the cosine of angle B. So now cosine of angle B is my variable, so I'm going to divide both sides of this equation by the negative 240.64. So as you see on my calculator, I've got that's what I came up with here. Let me walk it through. So I divided those two numbers and I came up with a 0.607. And then I'm looking for the angle B, so I did the arc cosine of that answer, and that's how big that angle is. So this angle is 52.6 degrees. Now I can just apply that that side angle side calculation to find out what the angle of that big whole white triangle is. Here, so let's make it a red triangle. So this red triangle we're going to find. So I'm going to do 1/2 times 12.8 times 9.4, because those are the two sides, times the sine of the 52.6 degree angle. So what I did is I went and I noticed that I had never calculated the yellow triangle, so I went area. So I went through and did that. And then I calculated the red triangle area, doing that formula I just set up. And then I added those two numbers together, and this is the area of that whole quadrilateral. Not an involved process. We don't have to learn another formula. That's one reason why I like this. Um, Now, if you do some searching on the internet about how to find the area of a triangle given all three sides, there's this thing you're going to find called Heron's formula, and I'll walk you through one. It's not my favorite method. It's because it's one more thing I gotta remember. Actually, I always have to go look up the formula to make sure I calculate this one number correct, because I never remember it. So here's the infamous Heron's formula, and the part that drives me nuts is having to calculate this S. So basically what you do is you have a triangle, add the three sides up divided by 2, that's what your S is. And you take away, subtract each side from, right, you take away each side from that S calculation, multiply that, take the square root of the product. And that'll be the area of the triangle. Now, to make this work, you need the three sides. So um, I think the only place this would save us maybe a little bit of time, and I don't know that it really does, is we have to find this third side in this triangle. So we still would need to use um, law of cosines to find that side, but finding the area of that yellow triangle is pretty easy. So you can do Heron's formula for the whole thing, just find that side, or you can use the area formula, that 1/2, uh, what the AB times the cosine of C or sine of C. Um, it's totally up to you what you feel comfortable doing. Some people like this Heron's formula. I'm not gonna put it down because it's useful. I just don't like it. That's me. So let's use it. Let's show you how to use it for the red triangle since I had to calculate that side. This will, the only thing this, to me, the only thing why I might make it slightly as attractive is I don't have to work that cosine formula backwards to get that angle. I've got all the numbers I need. Now I just need to calculate the area. So let's find S. So I know one side is 12.8 plus 10.3 plus 9.4, and I'm going to divide that by 2. My calculator tells me that that is 16.25. So that's the S number. Now let's do some setting up to find the area of that red triangle. So 16.25 is S. See how that's that there. Now we're going to take each side length in this red triangle away from S. So we can do 16.25 minus the 12.8 times 16.25 minus 10.3 times 16.25 minus 9.4. Once we get all those numbers, the product will take the square root. So here's what I got when I did all those calculations. I'm sorry, let's see, can I move some of this stuff out of the way? Oh yeah, that's the way to do it. Okay, so what I did was and let's get rid of this. That's what that is. There we go. So I found all those differences here, right? So this number here, this number here is that, this is that, this is that, and then I just multiplied, entered them all in my calculator as is, and I got 47.8 units for that red triangle area, which agrees with what I got with the earlier one. So now we just have to add that earlier, the yellow triangle area, which was, let's see if I can go back and find that on my calculator. Well, it'll be the same area. It'll be the same answer, right? Because I'm not changing my method for the other one. Yeah, so 19.7 is the yellow triangle area. So add those two together and I get my answer of 67.5-ish. So your choice. Do Heron's formula if you care to, do the law cosines if you care to, but it's not impossibly hard. The important part is setting up the drawing. So I did my workout on paper, and I did it both ways. I didn't get the same answers the book had, but I'm within a tenth. I'm within a hundredth one way, and I'm within a tenth. Actually, not even a tenth. I'm within a half a square centimeter for either way. So I think I've got it right. Could just be a rounding issue. So here's how I did it, finding the first method I did where I had to find that angle, and then here's the one using Heron's method. Certainly a lot less writing Heron's method, just visually what I'm seeing. So, it's totally up to you which way you do it. Hopefully this helps you be able to crunch that on the quiz question on week 14 quiz. And because it's just on paper, you're not trying to make WebAssign happy or my Open Math happy, um, it should be close enough. You can show me the setup, and you're in the ballpark, good enough.